Children are the future of our world. We all know that. I'm sure you all understand the significance of that truth. And as you're here today, I'm sure you know that environmental issues threaten that future. We need to address them before it's too late and create an environmental steward population that will carry on fighting against environmental threats.
Is the camera working?
Yeah.
Perfect.
Recognizing the pivotal role children have on the future of our planet, you can understand how truly necessary it is to equip them with the knowledge and experiences to navigate and analyze and hopefully fall in love with the complex topic that is the well-being of their local environment. Model My Watershed is a powerful tool for reaching this goal. Model My Watershed is a web-based GIS program that uses real-world data and scientific-grade model to provide kids with a meaningful connection to the local watershed and the issues at hand, by allowing them to model the changes in their local environment and seeing how it actually changes, such as when it starts to rain. You can think of Model My Watershed as a sim city for the scientific data. Instead of modeling your own world, you mold your actual world. You can transform your own world, your own town, even see the effects that each change will have, in a neatly organized graph that can easily be put into context. Model My Watershed serves as a powerful ally in this endeavor, providing a robust educational platform that empowers students to understand, analyze, and actively engage with the complexities of watershed science. By utilizing this tool in the classroom, we can cultivate a generation of environmental stewards. We're not only aware of the challenges, but also equipped to contribute to finding sustainable solutions. Through meaningful hands-on engagement, students have the opportunity to develop critical thinking skills and learn the intricate relationship between human land use and watershed health. Model My Watershed has gone through over a decade of rigorous field testing to ensure the best user experience for any age to just hop right in and start using it. Testing includes trials in real classroom settings, so let's transition to a demonstration. So you start right here by opening the website, modelmywatershed.org, and selecting the Get Started button. And from there, you are given multiple options to choose from, such as drawing your own boundary or selecting a watershed. We are going to draw our own boundary line for this demonstration. Does anyone recognize this? It's the happiest place on earth. This is Disney World in Orlando, Florida. So, when you look at Disney World, what do you see? Lots of blank white buildings with plain roofs and parking lots. Now, this is the worst case scenario for rainwater to drain through. So we're going to look at the different data points that is generated just from selecting the boundary. So you can see that there is a lot of medium to high density development and very low infiltration, low speed infiltration soil. So this means that there's a lot of buildings, a lot of blank pavement, and very bad soil for storm drainage. So here we have the model page. The easiest of these is a site storm model, which simulates a 24-hour storm. So it's going to show the amount of rain that is evaporated, runs off into the lake, or infiltrates into the soil. And from here, just the numbers, you can see that there is a lot of runoff. There's 8.6 compared to 5 centimeters of runoff. So this is one of the graphs that it shows. It shows the red is the runoff, the yellow is the infiltration, and the blue little sliver at the top is how much evaporates. And there is way too much runoff than is healthy. So right here we have the conservation practices in the land cover that you can place onto the map. So for this demonstration, we're going to use rain gardens. We're going to cover up all of the blank grass that is really just turf with the rain gardens, which is a divided point of land that drains water into a patch of native grasses and flowers and plants. And we're also going to put porous pavement, which allows water to go into pavement. So we're going to put that all over the parking lots, which are all over Disney World. We're also going to put green roofs on the blank white roofs that we were talking about earlier, and forests in the fake forest that they have in all of the attractions. And from this, we can see the difference that it makes. So on the left here, we have the predominantly forested model, which takes the area and kind of reverts it back to before it was developed. The middle is the current conditions, where there's way too much runoff and very little evaporation and infiltration. And on the right is our new, improved scenario, which takes all of the sustainable practices that we've put in place and gives them numbers. So here we have also a few different pieces of data that it tracks. This is the evaporation, the infiltration, the runoff, and the total suspended solids, which measures the amount of nutrients that's placed into the area. And you can see in the middle there on the suspended solids, that is the how it is right now with Disney World in place. There's way too much nutrients in the area. And with our changed one, there is maybe 1/6. Thank you. And if you have any questions, you can send it to the email on the screen. I have to say this, our project work was supported by funding through the National Science Foundation.
Perfect, thank you. Thank you. There's a quick question for Ben before we turn to like the collaborative and collective presentations that we had, excellent presentations. So, any questions for Ben specifically? Yes, Jerry.
Well, I think the obvious thing for Ben there and the theme parks is how do you get it across the US of A into all the theme parks? I mean, it's not his issue. What's the policy? What's the link with policy making to make that happen?
Well,
It's just a comment. I mean, I'm not putting him on the spot, but
He's ready.
obviously policy making can see that.
That's a great question. There is definitely a lot that has to be done in policy making. They're given some maybe financial incentives for companies to put sustainable practices in, just like how Germany has some for new development. So,
Yeah, and if I can add just a point here, policymakers continue to say, we don't know, we don't have enough data, so you now have the youth rolling up their sleeves, developing data. I don't know if you notice there's a slider where you can simulate lots of rain, less rain, so on and so forth. This is raw data, so it's not just youth saying, give us back our future, it's youth saying, this is what can be done today to improve our future for them. So it's a wonderful project, and I see the responsibility for WEEC, the World Environmental Education Congress, to begin to educate the policymakers on the fact that we have rising stars and data analysis, and we have to address the global south issue because we need those kinds of capabilities, not just in parking lots in the United States, but also around the world. So it's a great opportunity. Yes, you want to come in with a comment, please?
Okay, thank you for the presentation. I just want to add a quick comment about the runoff water, stormwater management. Because the state of Maryland, if I remember correctly, they implemented what they call the rate tax, which means that if you have a property covered by concrete and a lot of structures, you get to pay a a lot of fees to cover the cost to manage those stormwater. So it was a controversial tax in a way that you're just being charged for the amount of rain it comes down. But it was the kind of misconception that other states, other people who oppose to those kind of ideas, that oh, you're just charging people with rain. If you have too much rain, then you have to pay more tax or something like that. But it was kind of the conception that people trying to go against this kind of environmental idea that improves their lives, but many times they just distort the idea and then make sure that everybody go against those kind of system. But the idea of that kind of idea is already observed by the management authorities and state level governments and trying to implement in certain ways to improve their environment. So it's not completely, they are ignoring those things. Some, fortunately, liberal states are aware of these kind of issues. They're trying to implement a policy to improve our environments, in short. So just want to add that comment.
Thank you. Any last question for Ben before we have another 12 minutes or so, so we can open up for a broader question to bring in our other excellent speakers. But yes, please, in the back.
Thank you very much, Ben. Just a question in terms of how this fitted in within the curriculum in your school, in terms of was that integrated with, because I see a lot of maths there, I see a lot of science. How was that integrated within the school curriculum? And then the question is then how were you compensated in terms of, I'm not talking about financial, but in terms of recognition? Because we have a really, pardon my language, a screwed up system, education system in terms of rewarding our kids. We just kind of have these exams and stuff. How does this fit in the sense of providing this incentive that it becomes mainstream within our education systems?
Well, as it stands right now, we don't really have it in the curriculum. We would really like to. Right now, there's really just after-school programs that we run using the